on the topic of containers, this time with Gluster. Give a hand for Kaushal.
Thanks. Thank you, everyone. Okay, so today I'll be talking about Gluster Container Storage. That is storage for containers, running in your containers, similar to what Rook is doing with Ceph. So this is what Gluster does for containers, right? So I'm Kaushal. I'm a senior engineer at Red Hat, and I work on the Gluster project. I'm a maintainer, and I work mainly on the Gluster management frameworks. And right now, I'm contributing to the container story around Gluster. Right. So in today's talk, I'll talk about what GCS is. We'll go into a little bit more of detail about what GCS looks like, how it performs as in how it does what it does, and I'll let you know how you can try out GCS. Okay, so just a quick question first up. So has anyone already heard of Gluster in containers with something called Hecate, right? So yeah, this is GCS is built on our experiences that we gained with the Hecate project and running Gluster in containers with Hecate. So I'll touch a little bit about Hecate and try to compare what GCS does differently from the Hecate based stack in this talk. But yeah, so let's get started. So Gluster Container Storage, I'll be calling it GCS for short. Please don't get confused with GCS because in Kubernetes there is already GCS, which stands for Google Cloud Storage. It's not Google Cloud Storage, it's Gluster Container Storage. We would welcome suggestions for a better name. So for now it's GCS. I'll be calling it as GCS. Okay, so what is GCS? GCS is a new effort from the Gluster community to provide persistent storage for containers, right? So we try to provide the two normal demands of container persistent storage, that is the shared storage and the exclusive storage, the RWX and read write many and read write once volumes. We try to use the standard container interfaces as much as possible right now. So GCS implements, one of the projects in GCS is to implement the container storage interface or CSI, and using that we provide volumes when requested. For now we are Kubernetes only, but maybe later on if we get help we'll move on to other container orchestrators. And GCS is being designed for a hyper-converged deployment right now, as in your storage runs along with your apps on the same servers that your apps pods are running, right? So yeah, so while the storage pods run along with your app pods on the same nodes, these are not your normal app pods. These need privileges because we do deal with underlying devices, underlying file systems and all. So we need to run in a privileged mode, right? Okay. So GCS, right? It's not a single project. It brings together a lot of Gluster-related projects and under a single umbrella. So I'll go into detail about what each of the project does for GCS specifically. So we bring in GlusterFS that I hope everyone already knows about, right? So the file system, there's Gluster E2, that's the new management tool that we have been building. There's the Csi Driver specifically. There's Anthill. Anthill is a Kubernetes operator that will deploy and manage Gluster on Kubernetes. And there are other projects like Gluster Prometheus, which helps monitor Gluster inside a Kubernetes deployment. So basically you can plug in Gluster into your Kubernetes dashboard and you can drill down into Gluster volumes. Gluster Mixin provides the dashboard configurations, provides the alerts and rules, etc. Right? Okay, so now why would you want to use GCS over what we have currently with Hecate, right? So the main theme of GCS is to simplify the whole experience as much as possible, right? So we simplify how the containers get deployed, how Gluster gets deployed on Kubernetes. We simplify the general overall management workflow intended for the admins or users, right? We also go ahead and we are trying to simplify the GlusterFS stack itself. So and try to simplify the stack, the file system stack, and ensure that they work well for the container ecosystem. So what we do is that we try to make opinionated defaults, right? So right now, the normal GlusterFS installation doesn't do any opinionated default, so it just leaves it open to the users to what you want. Everything is enabled, everything is available, so GCS isn't that. So we choose features that need to be enabled, we choose options that need to be defaulted, and yeah, that's how GCS goes. Yeah, and all of this is going to be automated. So hopefully the most an admin needs to do is to write a manifest for Anthill, deploy Anthill, write a cluster manifest on Kubernetes, and done. So Anthill takes care of deploying everything that is required. So all the projects that I mentioned earlier, so Anthill takes care of deploying all of them, managing all of them. In the future, they'll also do day-to operations like replacing a node, upgrades, and other stuff. Right, and all of this together, right, allows us to improve our scale in the number of volumes at least. So GlusterFS originally wasn't designed for the container sort of environment. So GlusterFS was designed as a NAS replacement, wherein you have one single large volume or a few single large volumes. So, but in containers, you generally deal with lots of very small volumes. So GlusterFS isn't particularly designed for that, but we are doing optimizations. We are trying to figure out ways so that we can scale better. Our goal is to, I guess this is goal for a 3-node cluster, that is like the minimum for, if I believe, OpenShift that is required, that we can provide 2000 read-write, read-write many volumes and up to 5000 read-write once volumes. That's the goal. These are like small volumes. These are not really huge, so something that can run in a 3-node cluster. Right, so this is what GCS is going to provide. That is going to be different from the original stack. Right, so I'm not going to talk too much about the current stack, as I mentioned. We have a Hecate-based stack. So the Hecate-based stack looks somewhat like this. So we have a component within Kubernetes itself. So we are pretty much like tied into the Kubernetes release cycle. So we're not so independent. There's a Gluster provisioner within Kubernetes. We have a separate Hecate pod, right? Hecate manages the Gluster pods. And one big problem with Hecate, the base deployment, is that we have a Hecate DB separate with a Gluster configuration separate. So there are two separate views of the Gluster pool. Hecate has its own view, Gluster has its own view. And the problems that we see there are mainly about these two going out of sync. And recovery from that is hard. But a lot of work has been done on this, and right now a lot of it has been solved. But still, there is a problem with this. And in general, this stack relies on the normal Gluster deployment as the normal Gluster installation, as in without the opinionated defaults that the new GCS stack is going to provide. Right? So yeah, there are details available below in the slide. The link is available in the schedule. If you want to, you can look at this. So, yep, looking at it, it looks relatively simple, but deployment and managing this cluster is challenging. It's not easy. Right, so let's get into GCS itself. Right, so GCS looks like this right now. So there are few components. We have Kubernetes, we don't need to worry about that. So we have Anthill. Anthill is a Kubernetes operator, as I mentioned, that is going to deploy and manage the rest of these things, right? In addition to Anthill, we have the Csi Driver. That is going to be the point of interaction with Kubernetes for us. So Kubernetes talks to the Gluster Csi drivers. Gluster Csi Driver will then talk to the Gluster pods. In the Gluster pods, we have the new management tool running, GlusterD2. We have GlusterFS. We have the Prometheus exporter inside. And we also have an etcd cluster. That is our single source of truth right now. So the new management tool, GlusterD2, stores the cluster view in etcd. So GCS runs its own etcd cluster and doesn't make use of the Kubernetes etcd cluster, right? So yeah, okay, I talked about all of them anyway. So let's go into Anthill first, right? Anthill is a Kubernetes operator, right, which defines custom GCS resource definition. So Kubernetes provides base for what do you say, other projects to define their own resource types, right? Object types. So Anthill defines the GCS resource types in Kubernetes, and it automates deployment, upgrades, and day-to-day management of GCS. Right. At the current state, Anthill is very early. There isn't actually anything other than the CRDs. There isn't actually anything present yet. But things are. We are working on stuff. Things will come out soon. Anthill is developed under the Gluster project in GitHub at github.com/gluster/Anthill. Next up, we have the Csi Driver. So the Csi Driver consists of, okay, so as I mentioned, Csi Driver translates the Kubernetes CSI requests into the GD2 REST requests, the Gluster D2 REST requests. That's the main goal of these drivers, right? So in addition to doing the translation of the requests to create and delete volumes, right, it also will take care of doing the mounts. Unlike in Hecate, right, what would happen is the cluster provisioner in the Kubernetes, within Kubernetes, would take care of reaching out to Gluster or reaching out to Hecate. That provisioner would take care of doing the mounts. But in this case, we do everything via the Csi driver, so it gives us more freedom to do things the way we want, right? So the Csi driver consists of 3 different types of pods. There's a node plugin, there's a provisioner, and an attacher, right? I'll go through what each of them does. Okay. Attacher, provisioner, and node plugin, right? The attacher is, for us, at least in GCS world, it's a no-op. It's useless for us, but we just need to provide it because the Kubernetes CSI spec expects it. There is work going on to ensure, to allow CSI drivers without attachers. So not all CSI drivers actually require attachers to work. So the provisioner pod, right? This is the main pod for us right now. So this takes care of this is the one pod that listens for Kubernetes persistent volume requests or persistent volume claims, forwards them to Gluster, and yeah, that does it basically. It listens for the create and delete volume requests and forwards them to Gluster, translating them to the GD2 requests. So in this pod, we have, in this pod we have 4 different things running. So there is a Kubernetes provisioner, sidecar. So these, a few of them are provided by Kubernetes themselves. These are not developed by us, but yeah. So there's a Kubernetes provisioner. The Kubernetes provisioner's job is to listen for Kubernetes persistent volume object requests, and then the provisioner would talk via the CSI spec to the Gluster CSI driver, which would then relay that forward to the Gluster layer behind. So yeah, so there's a provisioner. We have a snapshotter sidecar, which takes requests, handles Kubernetes requests for volume snapshots, persistent volume snapshots. And there is a cluster driver registrar, which registers Gluster FS CSI as a cluster level driver, right? So it makes the Gluster storage available as a storage class, right? So that's what the provisioner does. This is deployed as a, right now, if I am right, a stateful set so that it's always available, running, and yep. Then we have the node plugin. The node plugin basically runs on every Kubernetes node that you have, right? Its main function is to mount the volumes when requested, or attach the volumes to the app pods when requested. So yeah, that's all it does. So there is a driver registrar. Again, it makes the Gluster driver available on that node for mounting. So there are 2 containers. The driver registrar makes sure that the driver is registered for, so that Kubernetes knows to reach out to the driver to perform mounts, right? So the node plugin pods, right, also contain the GlusterFS client bits. So you don't need to have the GlusterFS client bits installed on the Kubernetes hosts. With the previous deployment with Hecate, you needed to you needed the client bits installed on your Kubernetes host. So that was one more issue with that. So yeah. So then now let's go into the Gluster pod itself, right? So the Gluster pod has GlusterD2, GlusterFS itself, and the GlusterFS exporter. So first I'll talk about GlusterD2. Right, so GlusterD2 is the newer management framework for GlusterFS. It's intended to provide automated management operations for GlusterFS, as in automatically create volumes based on requests from the user, right? So a user can request for a volume of a particular size, of particular capabilities, and GlusterFS GD2 will automatically decide upon the layout of the volume and as the user requested and create the volume, right? In addition to that, it also tries to provide intelligent or automated volume management operations about, say, scaling a volume or shrinking a volume, replacing nodes, stuff like that, replacing bricks, stuff like that, right? So basically what it is doing is, it is converging the functionality of different tools earlier that were there outside the cluster, right? So we had Hecate running outside the Gluster pool, sorry. There was a project called Gluster Block, which is used to provide the RWO volumes or block volumes, right? These were running outside the Gluster pool, right? They were not directly managed by the Gluster layer. All of this is converged into one tool right now. So GlusterD2. GlusterD2 does the work of Hecate, right? Automated volume management, and it also provides block volumes in a different sort of way compared to Gluster Block. We'll see how it does it in a little while. Okay. So yeah, so GD2 provides a REST API like Hecate, right, against which you can program. So this allowed us to write our Csi Driver. We have an API that can be reached out to over the network to do operations. So the Csi Driver works on that. GD2 also has a very good orchestration engine built in, right? So it's more resilient to failures than the orchestration engine in the current cluster management layer, right? So we can do undos, we can do rollbacks if some operation failed. We can do an operation and say a node comes back up later, it can rerun the operation if required, stuff like that. So it brings in features to do more resilient orchestration of operations. So basically, the management framework, what it does at the end is that it needs to go to each node and prepare the brick, start processes, and do stuff like that. So the GD2 brings in a much better framework to do that. In addition, as I mentioned earlier, there is just a single source of truth for everything. There is no split in cluster information between Hecate and Gluster. So all the information is with GlusterD2. So GlusterD2 knows what all volumes we have, how the volumes are laid out, what all devices we have access to, stuff like that. So how many devices we have used, everything, right? So yeah, there is less possibility of failures because of the Hecate and Gluster going out of sync, right? In addition, GD2 also brings in support for Prometheus and OpenCensus so that you can trace or monitor GD2 with the standard tools that are used elsewhere in the container ecosystem, right? So Prometheus is widely used for monitoring within Kubernetes. OpenCensus implements the Open Tracing API. So again, we provide Open Tracing API endpoints so you can trace operations across the cluster if required, right? Yep. So as I mentioned, GD2 provides normal volumes as well as Gluster block. So the normal volumes are used to satisfy the Kubernetes RWX volumes or rewrite many volumes. The way how GlusterD2 helps there is that for normal volumes, there's automatic provisioning of bricks. So we go ahead and we create the LVMs, we create the thin pools, we create the file system on top of that, we do the brick mounts, we do all of that. GD2 takes care of doing that. And in addition, one special thing that we brought in was support for volume templates. right? So the normal Gluster installation would contain a volume template with everything, right? All the features that we provide. But for the GCS use case, for the container use case, you wouldn't need all of them. So if you had all of the features enabled in the graph, Gluster graph, it would be heavy. It would be resource heavy, right? So you don't need that. So we can provide a custom, simple template for RWX volumes for containers. Cool. In addition, we also provide RWO volumes, as in we also provide block devices, right? So block devices are meant for single users, right? Single client access. This is still a work in progress. Bits and pieces of it have been merged in. It's not complete yet, but yeah. So what this does differently from the Gluster block project is that this does block exports in a very simple way using loopback devices, right? So what it basically does is that you have a GlusterFS mount on your Kubernetes node, and from that mount, we create a image, device file or a image file, and then do a loopback mount so that it's available as a block device, right? The Gluster block project did its exports via Csi, and there was a lot of involved process in getting that set up. So that's more complex. Scaling was problematic there. This one allows us to scale really easily, much well. So, okay, so let's see the current status. Yep, so as of this moment, we can scale to, again, all of this I'm talking about in a 3-node cluster, right? We can scale to about 1,000 volumes, RWX volumes, and hundreds of requests parallel, as in hundreds of volume creation requests or volume deletion requests happening parallelly. So it doesn't bother G8. At this scale, we have begun hitting the limits of LVM scaling itself, right? So LVM, again, like Gluster previously, LVM itself wasn't designed for this sort of a thing. So Gluster uses LVM thin pools to provide snapshot capabilities. So we use LVM, so we need LVM. But right now we are hitting on LVM scale issues. We are trying to figure out optimizations in the way we perform LVM operations itself that can help scale a bit further. And we are also looking at other options, if possible, for RWO volumes. Yep. In addition to the LVM scaling, we also sort of hit HCD scaling when all of these requests come together. Again, we are tuning the HCD config itself, how we deploy HCD, and we are tuning how we use HCD itself. So as in how we store data in HCD, how we access HCD, right? Yeah, so we are doing that. And GlusterD 2 is also, again, developed as a separate project under the Gluster community. So it's developed under GitHub, GlusterD 2. Okay, so now let's look at what we have been doing in GlusterFS itself to help with GCS, right? So the main focus has been optimizing resource usage. So this has been in progress from the last few releases. So Gluster 5, one of the main topics was optimizing resource usage. Gluster 6, the upcoming release, is also, there is a lot of focus again on optimizing resource usage. So basically we're trying to reduce the memory that we use. So we are fixing a lot of the memory leaks that we have and everything there. We are trying to also optimize how we use threads, how we deploy it, and yeah. So we are optimizing resource usage. And again, there is this, I don't know if you have heard of multiplexing before. This multiplexing is a feature in Gluster where we run multiple bricks in a single process, right? So again, before GCS, it wasn't such a priority. It was okay, we wouldn't have thousands of volumes running. With GCS, with containers, we can't have thousands of processes running inside the pod, right? So we need to consolidate that. So yeah, we have multiplexing already for that. Multiplexing works for bricks, but there isn't a similar process for self-healing. So the volumes that we provide are redundant, as in replica Gluster volumes, Gluster replica volumes, right? So they need to have self-heal daemons running. Self-heal daemons right now are individual per volume. So again, there would be as many self-heal daemons as volumes that we have. So we need to multiplex the self-heal daemon as well. So that's work in progress. Okay. And there are other features like fencing. What is fencing? Yeah, so fencing is like a feature where we can ensure that only one client can access a file at a given time. So this is required for block volumes, so that we don't have clients or say now a pod was rescheduled on some other node. We don't want them to like begin accessing the image file before some cleanup has happened or some release of locks or whatever has happened, right? So things like that. So again, Gluster FS is developed under GitHub Gluster FS, right? Okay. Next on monitoring. Yep. So monitoring is developed under two projects. Again, under under the Gluster community, there's Gluster Prometheus and there's Gluster Mixins. Right. The Gluster Prometheus project provides us with the GlusterFS exporter daemon. This runs along with GD2 and exports the cluster metrics available, right? So it's not just the cluster level metrics that GD2 could provide. It's like per volume metrics, per bit metrics, process metrics, as in how much CPU is being used, how much disk space is being used, and all of that. So the Gluster Prometheus project provides this. And there is a Gluster Mixins project which provides rules and alerts, right, for Prometheus and for Grafana, so that you can build dashboards out of it. So right now, the Mixins project provides a dashboard configuration for a GlusterFS volume. There are others being built. Right. Okay. So I'm going to skip this. I was just going to talk about how the flow of operations was going to happen for a volume creation, but in simple terms, it's just straightforward, right? So it's Kubernetes to Csi Driver to cluster. Again, the same flow. Create a volume, mount a volume. It's like one flow, single flow. It's the same for both sorts of volumes because everything is in one place. There's no split. There's no Hecate, so that the request needs to go to Hecate or then to cluster, right? Okay. So, okay, if you want to try out GCS, just keep in mind that it's still in the very heavy development. We are planning on doing a 1.0 release sometime soon, where again it's not fully featured, but at least you can make use of it and just see how it works, right? So yeah, at the moment we have an Ansible-based deployment tool written. It's not a deployment tool; it's just a playbook that deploys GCS, right? As Anthill isn't complete yet, so we are depending on Ansible right now, and this playbook deploy gcs.yaml. This performs the full deployment right now, but as Anthill grows and gains more features, we'll be cutting down what the playbook does. So in the end, the hope is that the playbook would only deploy Anthill and we are done with it, right? So for more information on how to use the playbook to deploy GCS on your Kubernetes cluster, you can read the README. So the README gives you information on how to prepare the Ansible inventory files and how to run the playbook so that you can deploy GCS. All right. But if you want to just do a quick test on your local laptop, so we have a Vagrant file available which does this. It's Vagrant libvirt only for now because we do some adding additional disks and all that we haven't yet figured out on how to do for Vagrant with VirtualBox. Contributions are welcome to help do that. This Vagrant-based tool will deploy Kubernetes and GCS for you on a 3-node cluster, right? So Kubernetes deployment is handled using kubespray. We have a playbook that calls kubespray finally, but this playbook has some configurations that we need to enable for GCS to run, right? So we need to enable certain feature gates to allow the Csi driver to work. So Csi driver is still a work in progress in the Kubernetes community, so not all the features are enabled out of the box, so we need to specially enable some features for the Csi drivers. Again, more information on how to use this is provided in the README, right? So, yep, this deployment tool is available under the GCS project. So there is a github.com/cluster/GCS. Under this, we have a deploy directory where all of this is contained. So, yep, and that's basically it. Again, as I mentioned, GCS is being developed under GitHub Gluster GCS. So under this project, we mainly have the overall issues tracking the full GCS, worldview sort of a thing. And there is a waffle board which tracks the GCS related issues across the multiple different projects that I just described. So that's it. Please try out GCS and give us your feedback. And I'm open for questions now.
Hi, do you support extending volumes? Shrinking and extending.
Okay. So do we support extending volumes? GD2 itself supports it. The Csi driver doesn't yet. I don't know if the Kubernetes CSI spec supports it yet. So if that support comes in, we can build it. So the Gluster management layer already has support for automatic expansion. So we just need to do an extra call when that is available.
And in case of 3-node deployment, is it possible that, so I suppose all 3 nodes should have equal storage, equal hardware, yeah?
It would be preferable.
Preferable, yeah?
It would be preferable, but, okay, sorry. The question was, in a 3-node cluster.
That, for example, I have one server with big storage and 2 others with smaller one. Yeah? And on that big, I store some bricks and I provide only one replica for that. And for some other volumes, I ask to have, for example, 3 replicas. Yeah? Is it possible?
Okay, so I'll repeating the question. The first part was, is it possible to have non-homogeneous hosts? We'd prefer if you have homogeneous hosts, but GD2 should be able to work with non-homogeneous hosts. The second part was if you are able to choose the, redundancy count, or the replica count. Right now, we aren't targeting that because we want to simplify the number of options that users have for us to build confidence in what we are doing first. That might come in later on, right? So right now, we are, the Csi driver is hard-coded to create 3 replica volumes.
Oh, it's hard-coded.
It's hard-coded. So those 3 replica volumes can be created on a heterogeneous cluster, but the thing is, since it expects always 3 replicas to be present, if we can't individually provision bricks on each of the 3 nodes, the request will fail. So that's going to happen. But yeah. Any further questions? Yes?
How stable is GCS at the moment, and do you support upgrades between GCS versions?
Not really stable. Okay, the question is how stable is GCS right now? GCS isn't really stable. We haven't reached something that we would ask users to deploy in production yet, right? So the upgrade stories and all should be pretty simple, but we haven't thought about that yet. We have been just working on getting what we want to deliver in the first release fixed. So the upgrades for GCS would be simple enough because it would be just deploying the new version of the Gluster parts, right? All our configuration right now stays in HCD. HCD itself has its own upgrade mechanisms already defined for Kubernetes, so that's taken care of. The GCS parts themselves always rely on the information in HCD. So once we reach that stage, yes, it should be simple enough to do upgrades. Yeah?
How do you tend to handle doing upgrades if you have pods that are mounting volume? When you have to move mount points or something?
Yep, we need to do so. Okay, the question is how do we intend to do the upgrades, right? So if pods are mounting volumes and whatnot. So as I understand, there is some sort of, gating sort of capabilities in the Kubernetes operator world. I don't really understand the operator part of it well. So the operator would take care of doing that, right? So what the operator would do would be to bring down one particular pod, right? Then get a new version of the pod up and running, do whatever mounts is required inside that. Till that pod is up and running, it would block the upgrades of the rest of the pods, do stuff like that. Yeah. So it's not exactly clear at the moment, but I believe there is some way to gate operations to allow this to be handled in a smooth way. Yep. Any further questions? Nope. Thank you, everyone.
Thanks, Raja. Please provide feedback on FOSDEM.org.